So let's look at another cool feature that we can add to our API. Now we are going to look at rate limiting. I'm going to ask you to change to version 15 of the API. So I'm going to do it here. And now we have another decorator that implements rate limiting. So what is this? We don't want clients to abuse our API, so we are going to put limits to the number of requests that a client can send in a given amount of time. So we want to make sure that the API is available for everyone, all our clients, and this is the way that most APIs that have a large volume of customers are handling the abuse. So let me begin by showing you a demonstration, and then we're going to see how this is implemented. I'm going to run the application, open a new screen, and now let's send a request to our old friend, the customer list. I'm going to make it shorter. I'm going to say 1 per page. So here you see in the response that we have 3 new headers in our response. We are told that we can make 5 requests in the period. We are told that we have 4 remaining for this period, and then we are given the time when the limit resets. The way I have it set up, and I'm going to show you this when you see the code, is that every 15 seconds the limit resets. So we are allowing customers to send up to 5 requests in each 15-second period. So let's see what happens when we abuse the API. I'm going to try to send several requests here in a row. So I'm going to start 4, 3, 2, 1, 0, and now I have no more. See, any additional requests that I send are returned with 0 rate limit remaining, and I get a 429 status code error. I have sent too many requests. So now a few seconds have passed, so now we are surely in a different 15-second period. So if I send the request again, now it's going to go through, and again I have issued 1 and I have 4 more for this period. So this is the feature that we are going to implement. Let's see how this is done. So we have a class here that implements the rate limiting counting. For this example, I did not want to make things too complicated, so I implemented a in-memory counter. So we have this class called memRateLimit that will keep track of the counts for all clients in a Python dictionary in memory. Obviously, this is not a scalable solution. This will only work if you have only 1 worker when you are running your API in production mode. So in a production mode version, you will replace this with a database, and for something like this, a Redis database will be ideal because it's very fast, and you want this to be really fast because you're going to be doing it every time a client sends a request. But for this implementation, this is enough, and we are going to see how this works. Let's start by looking at the decorator. The decorator is called rateLimit. It takes a limit. This is the 5 that we set in the example, and period, this is the 15. So 15 seconds, 5 maximum requests in the period. I have here in the start of my wrapped function is to disable rate limiting if I'm running testing. This is very important because when you're running testing, you're going to be sending tons of requests really fast. So you do not want this decorator to intercept your test and ruin them. So when we are in testing mode and this testing variable is set in the testing configuration, if this is set, then we are going to let all requests through, no questions asked. But else, we are going to work with a limiter. And the limiter is the instance of this class memRateLimit. I'm going to store it in a global variable here. I mentioned that this is a simple solution for a one-worker application. So I have a global variable declared here above, set to none initially. The first time we get in here, I initialize it with a new object of the memRateLimit class. The way this is going to work is for each request, I'm going to generate a key that identifies the client and the function that the client requested. So I'm going to take f.name, and this is, if you recall, f is the original function. This is our route. So f.name is going to be the name of the function, in other words, the endpoint. And this is going to be the remote address from the client. So this is how I'm going to identify what I need to use to count limits on. So here I make my key, and this is going to be a key that I'm going to send to my limiter object. So I call the isAllowed method. I pass my key, my limit, and my period. And the limiter will respond with 3 items. It will say if this client is allowed, yes or no. This is going to be a Boolean, true or false. And then the remaining tries for this period, and then the time the counter resets for that customer. You can see here that I set my headers in a G variable. So in G, I'm going to store the headers that I want to add to the response. These are the 3 headers that you saw in the demonstration: the remaining, the limit, and the reset time. Unfortunately, I don't have a response here because I haven't called the original function yet. This is all things that I'm doing before I invoked the request. The whole point of this is to avoid calling the request if the client is over the limit. So I haven't had a chance to call the request, so I don't have a place to put these headers yet. So I'm storing them in G for now. If the client is not allowed, then I'm going to intercept this request. I'm not going to call the wrapped function, and instead I'm going to send a 429 response. If the client is allowed, then I'm going to call the original function, and this will let the request through. But we are still missing these headers. These headers were added in a G global. So now what I'm going to do is show you here in my after request handler that I just added to my create app function. I'm going to see if I have anything set in my G variable, and if I do, I'm going to stick those as headers in the response. So this way I am able to generate these headers at the time that I know the data that I need to put in them, but I don't have a response to put them into. And then I save them, and in an after request handler I can add them to the response now that I have one to use.